Hello everyone, myself Megha HR. I am the assistant professor in the Department of Computer Science and Application from C College of Science, Commerce and Arts, Autonomous. So today I'm going to give the guest lecture on the topic, the digital revolution in physics from calculators to scientific computing. So as you people know that when we was in our school age, all we was using like manual calculation. So we used to use our fingers to do the calculations. All later when we come to the plus two, we started to use the basic calculator. And when we come like major to our degree level BSc, so we started to use like scientific calculator because to calculate like tan, cosine, all even in the masters also. But as we people know that there is a lot of transformation in this physics subject where completely it is converted to the digital wise. Nowadays, in almost all the practical, sorry, in all the papers, science papers, we have the practical. Before all, in the max, all we was having only theory, but now we can observe that there is a practical paper, and they are using the softwares. Similar way here also in the physics also, we was using like some components, and we was doing the observations all, and we used to do some calculations finally to generate the results. But as the years goes on, so automatically we are using the scientific computing, means we are using some simulations, we are using some applications, mobile app or some softwares to get the observational value and to generate the result also. So now, this is mainly the turn was happened because of COVID. So everyone are know that before COVID, there was like traditional education. After COVID, it becomes like online education, modern education. And in the during COVID time, we have observed that most of the classes was taken through the online platforms, and they was covering the theory things. But when it come for practical, they were struggling a lot during that time. So some of the programmers, some of the software people, they started to develop some applications which makes the faculty as well as students to execute their experiments. So example, when I take myself only, so during the first wave I was like completely with the theory session. But when it come for second wave, third wave, so we can't stay like that only. So what I did, I started to search, I started to browse like for online compiler where we can execute the programs. So such type of programs, programming platforms I founded, application I founded, I suggested to the students. Even I learned and I suggested to the students. Same thing is happening in the physics also. And basically I'm from the computer science background, so I'll be showing how this computer science will be helping in the transformation of physics. Because we can say that electronics and computer will be related to each other, especially when it comes to logical gates all. But there is a relation between the physics and computer also, where the computer can be used in the physics concept also. So about that I'll be explaining in the brief. So, objective of today's session. So, first thing I'm going to say about tracing the historical progress. Next, advancing physics and physics experiments in programming language. And when it comes for all the students, they will not like the program. C program, they hate the C program, or they hate like some of the programs. But the latest programs we have like Python all. So about that also, how to learn the programming also will be covered over here. So first thing is tracing the historical progress. Okay. So as you can observe over here, sorry, we have like 5 progressing levels. So the first one is like early foundation before 1940s. So this is like before the first generation of computer. And here what happens, it was like completely like they was observing the values in the manually, or they was using some kit, and they used to get the they used to get some values on, and using the calculator or any physics related tool, they used to get the output. So mainly they was using like slide rules and analog uh, tools. So I hope analog tools, you people will be knowing that it will be like continuous formation. So this is also analog computer is also one type of computer where we will be discussing in the types of computer. So these are the main things, okay, like calculator. So such type of things they used to get the output in the physics experiment. And calculator is also one of the part of computer only, as we have observed. And next is the rise of digital computing, 1950s to 1980s. So here two types of computers will come. One is like mainframe computer and one more is personal computer. So mainframe computer, commonly it was used for commercial purpose, example like in the hospital. So as you people have observed that heartbeat rate, blood pressure. Okay, so they're all they'll be using this mainframe computers. And when it comes for like personal computer, this was particularly used by the researchers. So researchers means they will be doing like statistical analysis. They will get some values, they'll insert some values, and they are going to find the statistical analysis over there. So for that, they was using this personal computer. So only I have mentioned here as research. Next, scientific computing and simulation, 1980s to 1990s. So here we have supercomputer, numerical methods, and software development. So scientific computing, under that we can see best thing is a supercomputer. This is also one type of computer only. And this supercomputer was giving the future value. Example is weather forecasting. So what will be the future, what it is going to be happen, even weather forecasting, as you people have observed. So what will be the weather today, whether it will rain or not, such type of result used to generate over here. Next is like numerical method and software development. So as I told, like mathematical things also was calculated over in this systems, and they used to try to develop other softwares. So now example, let me take us like Microsoft Office. So that all comes under this numerical methods. So where we can have some functions and we can get the outputs. Example like logical functions or. And when it comes for like software development, as I told in the beginning only, there was like so many softwares, so many applications related to the physics, but we people was not aware of that. We are started to use only after the COVID, but they have started to develop in the uh, 1980s to 1990s only. And you people know that simulation, commonly the simulations will be like robots. Even the robots concept also was started in the 1980s to 1990s only. And next it comes like big data era, 2000s to 2010s, that is artificial intelligence. So artificial intelligence, nowadays everyone are saying like AI, AI, AI. So it's like nothing but like a computer, human computer, you can tell, where it will be simulating the human. Whatever work is done by the human, whatever thinking is done by the human, everything can be done by the artificial intelligence. So in the future, they may be telling that in the future, AI itself will take out our job. We don't want to come for the job only. Like teachers, there is no need of teachers. Only AI will make classes. It will conduct the class automatically. It will teach the students. That maybe happened also. So artificial intelligence also, it's one way of where it will be used in the physics, where like n number of data can be entered over there and n number of calculations can be done, and accurate result. See, we people can do the mistake, but computer does not make any mistake. It gives accurate results in this. And the last, and currently we are in this, and in future also we are going to use this, that is quantum computing. That the quantum age, that is 2020s to behind. So quantum. So here it makes like all our work very simple. So we don't want to struggle here. Automatically, the system itself will be giving the outputs. Okay, so just if we either we can say orally or we can give some data here, automatic the calculations will be done and it will be generating the output. So quantum computing is ongoing also. And when we people observe that, so from the first progress to last progress, in the first progress the manual working will be more, but when it comes for the last, the manual work will be very less. Okay, so next is advancing physics. So I have, according to my research, I have collected like four advancing physics. We have lot of things. So let me show about this four. So first one is like a virtual lab. So this is like where you can be at home itself, and through the home only you can uh, attend through the online, or you can enter to the app and you can execute your program solve. So you people will be aware of this virtual app all. So in this particular to the physics, we have like PHET interactive simulation. So what is this PHET means? So it is nothing but physics experiment. Okay, so experiment tool, physics experiment tool. So in this physics experiment tool, what you can do, you can give some data. So you can use like any input data and you can give over there and you can get the output. Apart from that also, usually when we want to construct any like example like mechanical physics, if we take, so what will happen, we have to take all components and we have to connect it. But in this we will be having one toolbox. So through the toolbox you can drag and drop and you can just give the connection and automatically it starts working. Okay, even in the digital electronics wire connections all we have to do, we have to give the conductor, inductor, semiconductors all. But here automatically the tools will be there on the right hand side. Just drag and drop and connect it according to your theory wise, and you can get the output. So regarding this, I'll play one video. So you can observe that as I told, she's dragging and dropping that components, whatever is needed. So you can see, and she's giving like connectivity according to the theory derivations. So so like this, you people also can do that. So usually this will be one of the best application where it can do in the system, or you can do in the mobile app also. But I hope the system will be very easy for that. And next, it comes for AI learning. Nowadays, all the peoples are addicted to Chat GPT. Everyone, so they have to use the Chat GPT for anything. If I ask, generate one letter, write a letter, Chat GPT. So similar to a Chat GPT, we have Albert Einstein also. So you people are know that Albert Einstein. So he's a famous scientist also. But here in the Albert Einstein, there is one advantage, okay, where you can have like previous data. Same thing will be happen in ChatGPT also, but here this is particularly for the physics only. You can use the like only related to physics concept only. And in ChatGPT, what will happen? Sometimes you will be getting like other meaning, different meanings also. But in Albert Einstein, exact meaning will be generated. So regarding that, So most of the students will be like searching the particular outputs. Okay, they want to get the particular definition, so they can make use of this Albert Einstein. So actually, you people can observe that previously I've asked some questions over here. So like whatever I've asked in the previous assault, that will be generated. Same thing like ChatGPT only. So you can give like whatever needed thing. Okay. So I'll give like physics. So you'll be getting the output for that. Okay. So this is about the Albert Einstein. So now we will go for the next one, that is mobile apps. So this is like a familiar thing where like once the COVID is happened, so all the faculties, students, they started to use this mobile app. So before that only it was developed also, but no one was using that. So here particularly regarding the physics, we have two things. One is Brilliant and Physics Toolbox. But to Physics Toolbox is the famous one. Like most of the common people are going to use that. As like widely it is used by most of the people, and it is very easy also. Like color detections will be done, and observations values will be taken place over here. So So there is one small video regarding this. So you can see that magnetometer. So like this, you can have like many types of physics tools here, and you can observe the values over that.
I've noticed that some mobile devices have covers that automatically, when they close, turn the screen off. And that happens because there's probably a magnet inside of that cover. As you see right now, Physics Toolbox magnetometer is measuring the background magnetic field, and you'll notice that the values are not at zero. In fact, the Earth has got its own magnetic field, and within different dimensions, it's recording a different value. So if I turn my mobile device, you might have noticed that some mobile devices
So like this, you can have like varieties of thing, and if you want to get the guide of this, so you can go through like some of the YouTube videos also, even that interactive also. So like interactive simulations was there, right? So regarding that also, you can go for like any of the YouTube videos, and you can get like guidelines over that. And next is data science. So name itself says as data. So where we are going to give some input data, and we are going to do some calculations, and we are going to get the output data. So that will be commonly happen in the data science. So regarding that, one small thing is like where we can use the programming languages. So we'll make use of some programming languages, and we are going to do. So here particularly, I'll show one small program already I have done over that. Speed. So usually we people will be addicted to paperwork. We'll be either use the paper or pen, pencil, and we'll do calculation using the calculator. But here there is a chance, not chance, there is, you can do, okay, where you can use some programming languages, and you can give some inputs, and you can get the output. So most of the basic programming language means that is C. So you people can see that I have used the C programming over here. So all the students whoever is studying computer, first they are going to study the C. But there should be like basic knowledge of the C. What is this void meaning? What is the function? What is this flower bracket? Such type of things should be they know. Okay. So first thing, this is like a documentation section, and these are two are like header files will be included. So this is called as include section. And next we have like compulsory, we should be having one main function, and the body of the main function will be this. And in the main function, first thing should be like variable declaration, like what all the input variables, what all the output variables we are going to use, of which data type should be mentioned over here. So I'm going to use like distance as d, time as t, and s as speed, and this will be coming under the float. Next, I have like clear screen. So commonly, if you want to get the new output in the new page, you have to use the clear screen. And printf is the output statement. Like if you want to print any message, okay, or if you want to print any value, then we use the printf. So here I'm going to calculate the speed. So whenever we want to calculate the speed, we have to enter the distance and time of the value. So that message we are going to get. After that, using scanf, I'm going to enter the d value and t value. So d will be addressing to the first float, percentile f. It is float, means because in the beginning we have given like float, right? So the distance should be of float and time should be of float. In case if you give in the integer also, automatically it will be taken as a float on. Next, use the formula. Speed is equals to distance by time taken. And next, printf speed is equals to percentile dot 2f percentile dot 2f and s. So here you can observe that speed is equals to percentile dot 2f I have given. Why I have given 2f means because sometimes we will be getting recursive numbers, right? To avoid that, we are going to give us dot 2. Okay. And next, after decimal point, only 2 numbers will be displayed. And here the speed will be, value will be printed. And getch is nothing but getchar. So if you want to get any immediate output, so you have to use the getchar. So now let me compile and run over here. So I will be getting enter the distance and time. So let me give my distance as 4 and time as 2. So I'll be getting speed is equals to 2.00. Again, let me try for one more. I'll give us like 7 and I'll give us 3. So automatically you know that you will be getting like 2.33333. So since I've given dot 2f, so after point only 2 numbers will be displayed here. So if you want any type of values you can give and you can get the output over here. So this is of the data science. So where you are giving like input data, calculating the data, and you're getting the output data. So that will be related to your data science. Next. So commonly you can use Python and MATLAB also. So MATLAB is particularly used in the max things, but here I have used like C program just to show that. Okay. So next, it is regarding the physics and computer. So where the physics experiments can be executed using the computer programming languages. First one is simulating physical phenomena. Now usually before all we used to show some videos all how the atoms or how the amplification will be moving, or how this current is passing. Okay, I know some most of the things we used to show in the videos all, or some of the things we was trying to show execute accurately, like execute directly. But now there is a chance of like where you can do physics experiment. Exact thing can be visible using the programming language. So here we have like Python, MATLAB, C, and C++. So when it come for like C++, graphics compulsory should be used. Similar way in the Python also, you have to use the graphics too. Without using the graphics, you cannot. Okay. So in that Python, we'll use like tkinter or any of the other graphical tools we are going to use over there. And in C and C++ also, we'll be using the graphics header file. So that only will be happen. Otherwise, simply if you are giving input and output, it's not possible. So regarding this, one small demo we have in this only C program. So as I told before only, so you have to use the graphics and DOS.h. DOS is for timings purpose, but graphics is compulsory. So usually this program was not done by me. When I installed the C program, like Turbo C, there was like so many graphics, but one graphic related to the Python, like related to physics, this program was there. So just I'm showing with that. So the codings, as I tell, codings will be very difficult only, but we have to practice with that. So according to how you want the simulations, so according to that, the coding should be given over here. Okay. Next will be automating experimental procedures. So here like C, C++ or Python. So here also it is quite similar to the data science only, where you can give some inputs and you can get some outputs. Okay, so in this case, in the automating experimental procedure, you can use like online compiler also, or you can use the offline compilers also. So I'll be just showing one small demonstration regarding this automating experimental procedures. So I'm going to use like Python here. Okay. Basically, however we want, we can do. As I told, like experimental procedure, right? You can go for like digital things also. One basic I'll just show, then I'll show the program over here. So we have an digital logical gates here. So I'll just show with that. Yes. So you can observe that I have given like print, true table and okay. And here I have used the for loop. So in the first for loop, 0, 0, next 0, 1, sorry, 1, 0, 0, 1, 1, 1. According to that, I'll be getting the like and here. So I have given like a logical operator and so I'll be getting the and truth table. Similar way for or also. So first case 0 and 0, 1 and 0, 0 and 1, 1 and 1. And here I have used the operators like or, so I'll be getting as or. And this is like not, okay. So this is already I've done, but I'll show with some small another examples also. Okay, so now just let me give us a run. So here inbuilt input is given. So directly I'll be getting the output. So you can see that. And 0 and 0 is 0. 0 and 1 is 0. 1 and 0 is 0. 1 and 1 is 1. Similar way for OR gate also. 0 and 0 is 0. 0 and 1 is 1. And simultaneously this will be 1. And this is if you are given 0, you will get true. If you are given as 1, you will get as false. This is like opposite. So, okay. So kindly, sorry. Okay. So first thing, as a programmer, you should be knowing that you have to give the documentation section. Compulsory, you have to give the documentation section. So here let me give my documentation section as speed. Okay, so I'm going to give as speed. So I'll show for that speed program only. That is like a familiar thing for everyone. And next, I have to give some two inputs over here. So in the previous case, the input was already in the program itself. Now, whenever you're giving like separately, so you have to use the input function. So we have going to use like d is equals to int input and just give us enter distance value. So if you want, you can give in the single quote also, or if you want, you can give in the double quote also. Anything is fine over here. Next, I have to give like t. T is equals to int input enter time value. Next, s is equals to d by t. So you can observe that we don't have any conio.h or we don't have any other declarations, or directly we'll go for input and we'll get the formula will be applied here and directly we'll get the output. So print speed equals put comma and just give us S. So now let me save. Before run, automatically they will ask for save. So let me save here. I'll give us speed. And here it will go for execution. So it is asking like enter distance value. So let me give some distance value like 6 and let me give us 5. So I'll be getting automatically 1.2. Here I did not give any float or anything. So default it will take as like string and I'm going to get as like 1.2. Okay. So this will be of your automatic experimental procedure, which can be easily executed using the Python program. Next, let me come for like data analysis. So we people are aware of this data analysis. What is data analysis means? We're generating of the graph, plotting of the graph, charts all. So we are very familiar with the line chart, bar chart, next pie chart, histogram, so on. And when it comes for physics, commonly line chart. We will just draw with the line charts. No? So we people, till now we was doing only experiment, calculation, observations all. But if you want to generate any graph or anything, so you can make use of this Python or R programming. And you can use this C also. But as I told in the beginning only, whenever you are using C, what will happen automatically? The coding start increase because it's a graphic related means the codings will be big only. So now let me use this Python coding only. So here new. Okay. So whenever you are doing any of the plotting of the graphs all, so you have to make sure that you should be using the matplot library. So that is must and should be used over here. So first thing, import matplotlib. And this will be having sub-library called as pyplot. So this is mathematical plotting library and Python plot. This is a submodule. Okay, so this is the main module and this is a submodule as PLT. So every time we can't use the complete name. So we are going to give the short name called as PLT. Next, so whenever we want to plot a graph, there should be two axes. One is x-axis and one more is y-axis. As we people know that the x-axis data should be given with the list of values, that is square bracket. So list means square bracket. So let me give us 10, 20, 30, 15. Y is equals to 30, 76, or let me give us less on. So 5, 16, 26, 3. Okay. So two sets of data has given over here. Next, what we have to do, we have to use the library short name and we have to call the function plot. So what is this plot? It will plot the line chart. If you want to plot a bar chart, you have to use bar. Pie chart means pie. Like this, for varieties of charts, varieties of functions will be there. And if you want to use this function, compulsory this library should be imported. And sometimes the library, if it is not if it is not installed, then you have to go for command prompt and you have to install with that. So you can refer any of the YouTube videos, so where you will be getting the information like pip install the library name. Okay. So here we are going to plot like x and y. And next, plot dot show function. Okay, so here I have not used any extra thing like py plot x label, such type of things I have not used. So if you want, you can make use of that also. So just I'll save over here. Plot 1. Yes, you can observe that. So the data, how it has been moved from here to there. Okay, so now let me change over here. Okay, I'll give like properly. So because I'm not given like randomly everyone, no? So let me give in the proper way. So 10, 20, 30, 40, 40. Let me give us 40. And here, according to that, 2, 8, 1, 9. Yes, now you can see that. So how you are giving the data according to the plotting will be. This is like 10 2, and this was like I'll show the coding also. Just yeah, sorry. Yes, you can see that 10 2, 10 2. Next 28, next 31, and 49. So according to that, the graph has been plotted here. So similar way, if you want to plot like a pie chart, the pie chart also can be done. Or if you want like bar chart, the bar chart also can be done. But bar chart, let me show with that also. So if I, so you can see the bar chart over here. So the bar chart has been derived here. So however you want, you can do with that. So if you want like to label the x axis, y axis, that is also possible. You can just use like a plot x label. Okay, so I'll just show here. Plot dot x label equals to, sorry, x axis. So you can see that previously this labels was not there. Now you have got the labels. But whatever you're doing, it should be done before the show only. So in our example, if I just remove like X, okay. So here I'm going to, sorry. So let me give us like, let me remove the X. So what will happen? Sorry, y. Okay, I'm going to remove the y miss. So on the y axis, I'll not get the label. Even coloring changes also can be done. Whatever editing, if you want, you can do that with that also. So now you can see that only like x axis is same, y axis is not same. So, but this one, whatever editing you're doing, everything should be done before the show only. Okay. So this is of your like data analysis where using this Python, particularly Python, you can generate any type of graph over here. So next, this concepts all will be covering like a physics experiment within the programming languages. So when we people, when I go to the classes, almost of the students will say the science subject is very difficult. All, but according to me, the science is not difficult. It's very easy. But you people have to make it simpler. Okay, so we have like lot of tools we can practice at home only, and even now they'll say there is no any distance education for the physics, like a especially for science. They will say no, being at home only, you can execute the programs, you can execute some experiments, and you can get the output. So this will be ending with my presentation. Okay. So just thank you for giving this opportunity. And if any queries, you people can ask me.